All right, AMP1 students, in this video we are going to focus on covalent bonds. I'm going to show you which learning objectives are going to go along with this video. So in our last video we talked about ions and ionic bonds. And so this video we're going to describe what a covalent bond is, and we'll explain the difference between the two types of covalent bonds. And the two types are nonpolar and polar. We'll talk about the four most common elements in the human body and talk about how they are the ones that generally are going to form covalent bonds with each other. And then we'll see the difference between a single covalent bond, a double covalent bond, and a triple covalent bond. All right, so I'm going to go back to our chapter here. And if you remember in the last video, we talked about how some atoms meet the octet rule, and they can gain stability by losing electrons or by gaining electrons. And so remember, those were like, the examples were like sodium can do that, chloride, potassium, magnesium. Those are examples of atoms that gain chemical stability by meeting the octet rule. By what they're going to do is like gain electron or electrons, or donate or give away an electron or electrons. So with these atoms in this video, we will talk about how they meet the octet rule and gain chemical stability. And they do it by sharing electrons. So they're going to share the electrons. And the examples of atoms that are going to meet the octet rule and gain chemical stability are the carbon atom. And let me slide down here because I know it's in here in our list here. Yeah. So the carbon atom, the hydrogen atom, the oxygen atom, and the nitrogen atom. So those are the four that are the most common atoms that are gonna interact with each other and form covalent bonds. And realize that they are the most numerous of the atoms or elements within the human body. Okay, so whenever they form and share the electrons with each other, they're going to make these larger molecules. And so that's what you get with covalent bond, is a molecule. And so examples of molecules, you know what we're talking about, would be like a protein. So like a protein has these particular atoms that compose it. Another example would be a carbohydrate, like glucose, which is the sugar that's in our blood. Another example is a lipid. So cholesterol would be an example. And again, these are all examples of molecules that have these particular atoms within them, and they're forming covalent bonds with each other, so they can form these big molecules. All right, so when two atoms share electrons, we call that an attraction. And the attraction that we get is the bond. So we'll call it a covalent bond. And that's going to allow for, making these really large molecules like the proteins and the carbohydrates and the lipids, even DNA. So, okay, so that's a little overview on the definition of a covalent bond and the main atoms that are going to form covalent bonds with each other. So now we want to go to that objective where we talk about there's two different types of covalent bonds. And the first one we'll talk about, it's called nonpolar. So a nonpolar covalent bond. And then the second type that we'll talk about is a polar covalent bond. All right, so I'm going to use pictures to show this. And they have pictures in the textbook, but I'm going to use this picture here, because you kind of see like the two particular molecules, even though we're using fluorine, and not carbon, hydrogen, oxygen, or nitrogen, but but it kind of shows these two molecules and what they look like before they form a covalent bond. So, all right, so remember, covalent bond is the sharing of electrons. And we have two types. So this top picture in this box is showing a nonpolar covalent bond. And then the bottom picture, we're going to look at a polar covalent bond. And if we look at them side by side, hopefully we'll be able to remember the difference between these. Okay, so remember, the sharing of electrons, that happens so that these atoms can meet the octet rule and gain chemical stability. So you can see that this particular atom has 7 electrons in its outer electron shell. So there's 7 of them. And then we have another atom with 7 electrons in its outer electron shell. So when these two attract to each other, form an attraction with each other, what they can do is they can share their electron with the other atom. And so when they do that, now if we look here, now we have this particular electron shell, the outermost one, with 8 electrons, which that meets the octet rule, so it's chemically stable now. And then this one also has 8 in its outer electron shell. So they're sharing a pair of electrons right here. All right, and we say remember this is our example of a nonpolar covalent bond. We say that they are sharing the electrons equally. So they're going to share the electrons equally. That means that these two atoms, they have the same attraction for those electrons. So those electrons that they're sharing are going to orbit around this atom the same amount of time that they orbit around this atom. So they share them equally. And because that's the case, these two atoms don't have a positive or a negative charge because their number of electrons equals their number of protons. So they're neutral. They don't have a charge. All right, so that's the example. And the definition of a nonpolar covalent bond is when two atoms share electrons equally. And thus they don't have a charge. They're both neutral. So no positive or negative charges anywhere. All right, so the second type is the polar covalent bond. And we're going to look at it down here. And they use water. Water's a really good example of a molecule in the body that shows polar covalent bonds very well. So we're going to use this example. So we have oxygen atom here. And you'll notice that it has 6 electrons in its outermost electron shell. So, and we know that it needs 8 to gain chemical stability, meet the octet rule. So what it wants to do is share electrons with some other atoms. So it's going to do this with a hydrogen atom. And remember hydrogen's kind of the exception to the octet rule because it only has 1 electron. And so it only has this innermost electron shell. This is like it's the only one. So it can only hold 2 electrons. And then if it does, then it's considered meeting the rule, not so much the octet one, but meeting the rule that makes it chemically stable. So what's going to happen is the oxygen is going to share an electron with this hydrogen atom, and the hydrogen atom is going to share an electron with the oxygen. So they will form an attraction here. So, and then this is the little attraction that we see. So that helps because that takes care of this hydrogen. It now has 2 electrons in its outermost shell, so it's good. It's chemically stable. But then oxygen at this point only has 7. So what we want to do is oxygen's going to share an electron with another hydrogen atom, and if it does it the same way as this one did, then we get 8 electrons in the oxygen's outermost electron shell. Meets the octet rule and is chemically stable. So we call these bonds or attractions between these two atoms and this one, we call each one of those as a polar covalent bond. Okay, so the reason that we call them polar covalent bonds is that this oxygen atom has a stronger attraction for these electrons than the hydrogen atoms. So what that means is these electrons are going to spend more time orbiting around the oxygen atom and not as much time orbiting around the hydrogen atom. Because that happens, they're not sharing the electrons equally. So there's going to be more often more electrons than protons when we're looking at the oxygen atom, and there's going to be more protons than electrons when we're looking at the hydrogen atoms. So what that'll cause is a slight, it's not a full positive or negative charge like we did with the ions, but it's a slight charge. So what we'll get is the oxygen, because it has electrons, the ones it's sharing, spending more time around it than the hydrogen atoms, it'll have a slight negative charge. And then the hydrogen atoms, because those electrons are not spending as much time around its nucleus, it's going to have more positive protons than negative electrons. So it'll have a slight positive charge. So this one will have a slight positive charge, and that one will have a slight positive charge. And then the oxygen will have a slight negative charge. And again, that's because they're sharing the electrons unequally. And that's the definition of a nonpolar covalent bond. So this will become important when we start talking about water and its properties. Because it's polar, that it's able to have some properties that we benefit from, our human bodies benefit from. So okay, so I'm going to end this video. That was just the breakdown of our covalent bonds and the definition, and also the four main atoms that form covalent bonds, and they are the most numerous atoms in the human body, and also the difference between the nonpolar and polar covalent bonds. And I'm glad I looked at this because we forgot to talk about single, double, and triple. So real quick, the single covalent bonds, what that means is the two atoms share one pair of electrons. So if it's single, they share one pair of electrons. So then you can probably guess double is going to share two pairs of electrons. And then triple will share three pairs of electrons. So I think I have time. Let me go to the book real quick, and they have a picture showing each one of those. So a single covalent bond, so these two hydrogen atoms are sharing one pair of electrons. A double covalent bond, you can see that there's two pairs of covalent bonds being shared between these two oxygen atoms. And then the nitrogens here are sharing three pairs of covalent bonds, three pairs of electrons. So it's considered a triple. So that's the difference between single covalent bonds, double covalent bonds, and triple covalent bonds. Okay, we'll see you in the next video.